Okay, so this video is going to be a little ugly. I'm going to be writing with my finger instead of my pen. Sorry. We are going to have a word problem on Friday's test, just like on this class opener. It says Jack has a jar of nickels and dimes. He has 87 coins in that jar. The total amount of money in the jar is $6.25. So we need to come up with, I guess, some instructions on how to create a system when we have these type of word problems that involve money. So let's first create an equation based on the number of items that you're dealing with. So we're going to create an equation based on the number of items in your situation. So what are we dealing with, guys? What kind of items? Are we dealing with movie tickets? What are we dealing with? Money. And what kind of money specifically? What kind of coins specifically? Nickels and dimes. So obviously we have two items, right? And we have two variables. So you could label them X for nickels, Y for dimes, or you could just say that N is going to represent the number of nickels and D is going to represent the number of dimes. So we know we have a total of 87 coins. So N is going to represent the number of nickels. That might be 10 nickels, it might be 50 nickels, but N is going to represent the number of nickels. And we are going to add the number of dimes, so we're going to write that as D. And we know that how many total coins are there? 87 total coins. So that is an equation that was created by reading the question and representing the number of items in your situation, right? We have coins. How many coins? We don't know exactly how many nickels and dimes, but we know that total is a total of 87 coins. So now we want to create an equation based on money. So when we create an equation based on money, we want to be specific to the actual worth, right? So how much is a nickel worth? 5 cents, right? Okay, obviously. So if I had 2 nickels, then I'd have 10 cents. If I had 3 nickels, I'd have a total of 15 cents, right? Talking about money. So since it's 5 cents each nickel, I need to put that numeric representation of 0.05 for each nickel. 0.05 for each nickel. Because if N represents the number of nickels, if N is 3, then you'd have a total of 15 cents because 5 cents times 3 is 15 cents. Or if you had 10 nickels, then that would be 50 cents because 0.05 times 10 would be the 0.50, which is 50 cents. How about dimes? What am I going to represent for dimes right there? Plus, how much is a dime? 10 cents. So I'm going to put 0.10 and then put a D right next to it. Because if I did have 5 dimes, then that would be 50 cents. Because 10 cents times 5 would be a total of 50 cents. So the second equation is based on money, and we have to be very detailed with how much each item is worth. So a nickel is worth 5 cents, a dime is worth 10 cents. And we know that when we add it together, we have the grand total of the money that it's worth inside of the jar. And how much is that, according to our word problem? $6.25. So ladies and gentlemen, that is our system. So once again, the total was $6.25. You first create an equation based on the number of items and then create an equation based on money. So there's our system. What I want to do now is solve the system using linear combinations. What's confusing about this equation? That we have decimals in it. So how could we get rid of decimals? By simply multiplying by 10 or by 100 or by 1,000, depending on how many place values you want to move. So if I want to move this decimal place over 2 spots, so it'll change from a 0.05 to a 5n, I would multiply by 100. I want to multiply everything by 100. This by 100, that by 100, that by 100. Okay. In other words, I want to be moving the decimal place 2 spots on each and every one. So this is going to be a regular 5n when I move it over 2 spots. When I move it over 2 spots, it's going to be a 10d. When I move it over 2 spots, it'll be a 625. So let me rewrite the bottom blue equation over here. Multiplying everything by 100, it'll give me a 5n. It'll give me plus 10d and it'll give me 625. That's moving the decimal over 2 spots. That's multiplying everything by 100. Now, the top equation, I don't have any decimals. It looks pretty nice. It's just one N and one D and 87. I need to change. Well, first of all, let me ask you this. Do you guys want to cancel out N's or D's? Let's go with N's. So I'm going to cancel out this N, which is a 1N. I need it to cancel with the 5N. So what am I going to multiply by, that top equation, what am I going to multiply by to get it to cancel with the positive 5N? A negative 5. Thank you. So when I distribute to each and every term, I'm going to have a negative 5N. I'm going to have a negative 5D. And I'm going to have a negative 435. 5 times 80 is 400. 5 times 7 is 35. 435. Negative 435. I should probably double check that on a calculator. Calculator. Here we go. Okay, I'm going to assume that I'm right there. Now it's ready to combine and cancel. So the 5N's, they eliminate. The negative 5D and the positive 10D, that gives you positive 5D, equals 625 take away 435 on a calculator gives me 190. So I have that simple one-step red equation that says 5D equals 190. All I have to do is what? Divide by 5, divide by 5. Of course, the calculator's nice. 190 divided by 5 on a calculator is 38. So what did I just find right here, guys? What is D? The number of dimes. Exactly. D is the number of dimes. So I have 38 dimes in that jar. I need to find out how many nickels are in that jar. So how could I do that? Plug it in. Just like before with x's and y's, once you have an x value and you want the y value, just plug it back into the original. So I'm assuming you guys don't want to plug it into the equation with decimals, right? You guys want to go with the top red equation? It looks nicer. So let's say n plus d equals 87. N plus d, but I'm going to put the 38 in there instead of d, equals 87. So like I said, I'm going to put a 38 right here in place of the d. So it really just says n plus 38 equals 87. So what number plus 38 equals 87? If you want, go ahead and show your work by subtracting 38. Subtracting 38. And we're going to have n equals 87. Take away 38 on a calculator is 49. So how many coins, or what type of coins did we have in this jar? We had exactly 49 nickels and 38 dimes. Now let's say you weren't too sure about this. What could you do to make sure that you got the right answer? Plug both numbers into the equation or the real life situation. So if this is correct and I have 49 nickels, I should be able to do on a calculator 49 of those nickels. How much are the nickels worth? 5 cents. So you could go 49 times 0.05 on a calculator plus 38 dimes. 38, how much is a dime worth? 10 cents, 0.10 in a calculator. And that should give us the total answer on our original problem, which was $6.25, I think. Let me check. So 49, open parentheses, 0.05, close parentheses, plus 38, open parentheses, 0.10, close parentheses, hit equal, and it does give us $6.25 on a calculator. So just by doing that, I know for a fact that I have the right answer, 49 nickels, 38 dimes. So we are going to have one word problem on Friday's test. This was the very first one we've covered. You'll see another one tomorrow, another one the day after that. You should get more comfortable and ready for them by Friday. Okay, let's take a look at the rest of the class opener. So we had graphing inequalities, and let's take a look at number 2. This is a review from a long time ago. Graphing an inequality, it's the same thing as graphing a line. You need to make sure that it's in what form? Anybody? We want this form, y equals mx plus b, slope-intercept form. Obviously, this is not y by itself, so I need to get rid of this multiplication of 2. So to do that, you do the opposite, divide by 2. And what you do to one side, you do to everything. You do to the other side. So I'm going to divide each one of them. That 1x, I'm going to divide it by 2, and the 4, I'm also going to divide by 2. So my new inequality is y is less than 1/2 x minus 2. And this inequality is now in slope-intercept form. It's ready to graph. And that's what I'm going to do. So let me just draw a quick xy plane sketch. And according to this y equals mx plus b inequality, where does it cross the y-axis? -2, -1, -2. So I'm going to put a dot right there. And then from that dot, sorry, it's an ugly dot. From that dot, I'm going to go up 1 over 2. So I'm going to go up 1 and over 1, 2. Let me actually draw. There you go. So up 1 over 2 is going to be right here. And then up 1 over 2 is going to be right there. And we know we have the line that runs through this way. Okay. Now the question is this going to be a solid dot or a open or a dotted? Solid dot. Is it going to be a solid line or a dotted line? It's going to be a dotted line. Remember, if it has a solid line underneath your inequality, that's when you draw a solid line. But it does not have a solid line underneath it, so it's going to be dotted or dashed. So I'm just going to put some dots. And then on top of that, you can put some arrows. But then you need to know what side to shade. You either shade in this upper part or you shade in this bottom part. And you do that by testing a coordinate to see where your answers are at. So if we test the point 0, 0, which is clearly up here above that red dotted line, if we test it on the original, it's going to say 0 for y, 0 for x. What's 2 times 0? 0. Okay, the inequality is less than. And how about over here? What's 0 take away 4? 0 take away 4 is what? -4. So when you think about this situation, 0 is less than -4. What do you say about that? False. That's false. That's not true. 0 is not less than any negative number. 0 is greater than any negative number. So what do we know about this point 0, 0? Did it work? It did not. So it's not an answer. So where are my answers at? On the other side. So I shade in the bottom part of this dotted red line. This is a review. We did this a long time ago, but we need to know it on tomorrow's section of graphing systems of inequalities. Just a little review. Let's try the next one, number 3. So this guy is not even ready to graph yet because it's not in slope-intercept form. What's my first step? What should I do first? Subtract 3x, thank you. That'll cancel out. What I do to one side, I do to the other side. Subtract 3x over here. Let me rewrite everything. I'm going to have a -3y, a less than or equal to a -3x, and a -6. Now it's still not in slope-intercept form. I need my final step. What do I need to do? Divide by -3. Divide by -3, divide by -3, divide by -3, and now it will be in slope-intercept form. What would that final slope-intercept form equation be? Let me do it in black right here. Y, what? It changes the sign. It used to be less than or equal to. Now it's greater than or equal to because we divided by a negative. Remember that. On inequalities, whenever you multiply or divide by a negative on your last step, you have to flip that inequality symbol. Anyhow, what about the rest of this inequality? What do I have? What's -3 divided by -3? 1x, right? 1x. Or you could put it 1 over 1 if you want. And then plus 2 at the very end because -6 divided by -3 is +2. This is your slope-intercept form inequality. Now all we have to do is graph it. So I'm going to draw a quick xy plane. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, that's ugly, but it's just a sketch. It crosses where? What's the b value? 2, right there. Whoops, right there. Okay, now from that point, what do? Up 1 over 1, up 1 over 1, and so, oh, that's ugly. Up 1 over 1. So we know we're going to get, and backwards, down 1 over 1 the other way, down 1 over 1 the other way. We get that diagonal line. The question is this going to be a solid line or a dotted line? Solid, because it has a solid line underneath here. So I need to do a solid line right through there. There it is. Arrows. Now I need to shade in either this top part or this bottom part. It all depends where our answers are at. So if I test the point 0, 0, that's the easiest one to test. If it works, I shade in down here. If it doesn't work, I shade in up here. So let's go back to the original. And if I plug in a 0 for x and a 0 for y, it's going to say 3 times 0, that's 0. 3 times 0, that's 0. 0, take away 0, that's still 0. Is 0 less than or equal to negative 6? Is 0 less than or equal to negative 6? That is false. So what do we know about the origin? That it did not work. The coordinate 0, 0 did not work. So where are my answers at? Up there on the other side. So let's draw a shaded part on the top part. And that's about it. You will need to know this stuff on tomorrow's section. Not today. This is just review, but you need to know this for tomorrow's section. So we are going to be working with word problems, which we did on this class opener, and also graphing inequalities tomorrow.